Good morning guys, welcome back to another video here on Unplugged TV, sunny hot Australia. Look at this weather. Okay, today I want to do some testing on the Teslander again in regards to the charging options you have at home. I would like to find out what kind of charging is the most efficient for the Teslander. We will explore charging via the UMC, which comes with the car, the original Tesla wall charger, 50 kilowatt DC charging, and of course Tesla Supercharging. Which of all these possibilities is the best and most efficient to charge up your Tesla? So in our test setup we have the Sonoff device here, which delivers the power. It is kind of like of a meter. You can see the voltage and the amp and the kilowatts going into the car's charging system. This is what you have to pay for. Yeah, the Sonoff feeds power to our power point here where the UMC is plugged in, and then of course the UMC feeds into our car's system. The charger is built into the car, so we cannot measure anything in the car, but well, because we have the Tesla watchdog running on our mobile phone, we can actually read the data directly from the car's system and can see how much power goes actually into the battery directly after the charger. And also prepared our little whiteboard here with a table, so we can write down all the numbers and see which charging method is actually the most efficient and has the least loss. Okay, so I will turn off the air condition now, because otherwise we will have a different result, of course. Let's wait until this one goes to 0. I've got the Tesla watchdog prepared to show us the voltage of the battery and the battery current going in and out of the battery. So this is almost on 0 now. The car is not turned on. Alright, so we are zeroed out. 2.17 watts is the standby power of the EVSE of the UMC when just plugged in, but the car is not charging at all. And we have 243 volts at the UMC, or at the Sonoff. Okay, so we set the charging limit to 5 amps. And set the limit to 70, it doesn't matter. Set limit. So the car is charging, start charging straight away. And we will see this ramping up in a moment. There we go. So we are charging now on 5 amps. And we can see 5 amps going into the Sonoff. And this one shows us 2.4 amps. This is what we get into the battery. So 5 amps shows us 1.2 kilowatt. The display shows us 5 amps, 240 volts. 5 times 240, 1.2 kilowatts. And the watchdog shows us 366 volts in the battery times 2.4 amps, 2.5 amps, 915 watts in the battery, 0.915 kilowatts. Alright, so we're putting 1.2 kilowatt into the car, but 0.9 kilowatt is only coming to the battery. This results in a loss of 23.7%, so we've got a 76% efficiency while charging on 5 amps. Okay, let's ramp up this charging to 8 amps. We've got 8 amps now on the Sonoff. This is what goes into the whole system. And 1.88, 1.9, can we say 1.9? 1.9. The display shows us 8 amps times 238, 8 times 238, 1.9, and the dog shows us 367 times 4.4 is 1.615, 1.615 kilowatt. Okay, so charging with 8 amp, we already have a benefit and the loss is only 15%. So we've got an efficiency of 85%. I'll do the maths for 10 amp and 12 amp, and then we hook up the Tesla wall charger with 3-phase power and see what we get there. So I've done all the calculations for 5 amp, 8 amp, 10 amp and 12 amp, and as a result we can see the higher the setting, the less loss we have, the more efficient the charging is. So on 12 amp we have only 10% charger and cable losses, while on 5 amp we have 24% charger losses. Okay, let's plug into the 3-phase. I don't have 3-phase here. Let's go somewhere where we have a 3-phase charger. We are going to the good old University of Queensland, Gatton campus. Man, I haven't been here for ages. Okay, so what I will do, I will set the charge limit to 70%, open the charge port. All right. Oh no, what do I see here? Okay, so we turn off the air conditioner again, change this one to 5 amps. So we are charging on 5 amps, but 3-phase. See this little 3 there? 3-phase. Of course, unfortunately, we don't have the sun off anymore, so we don't know exactly how much power goes into the destination charger. But from what we can see here on the display, it shows us exactly the same as the sun off did. So there was not much difference. And I think we can safely use these numbers here on the display. So 5 amps times 3-phase times 245 volts. So, and because we have 3-phase power now, we cannot simply just multiply the current and the voltage anymore. We have to multiply this with the square root of 3 for the 3-phase power. So basically multiply it by 1.723 or so, I think. So 1.7 is enough for us, just to give us an idea. So we have 5 amps times 245 times 1.7 joules, and this will give us 2.1 kilowatts. Right. Okay, let's crank this one up to 10 amp and 16 amp, and I'll do the quick maths here. Okay, I made a mistake because we have 240 volt in Australia. We don't have 400 volt line voltage, but 415. So I did all the calculation again. 5 amp, 10 amp and 16 amp on 3-phase. These are the, this is the power the display shows, and this is the power the Tesla Watchdog shows. So, and as we can see, on 5 amp we have a loss of 7.5% only. On 10 amp we've got a loss of 4.6%, and on 16 amp we've got a loss of 4.7%. So this shows us that at 10 amp already, well, this is the minimum loss we get while charging on AC, which you can achieve on 10 amps already. This is the minimal loss the internal charger will always have, this 4.6 or say 5% loss. We cannot get better than this. And we know the internal charger has 11 kilowatt 3-phase here in the Tesla Model 3. So from this shady table here, we can already see that the internal charger performs the best when it is at this maximum power. So the slower you charge, the more loss you have. Yeah, so 5% is the minimum loss the charger always has. It cannot get better. Okay, Ah, they put a little sign up here. That wasn't here the last time. Charges apply. After charging, maximum 1 hour. Please move your EV to allow others to use the charging station. So, this is new. A maximum charge time is 1 hour now. Yeah, stop charging. Unlock the charge port. I'll clean up the cables later. This is ridiculous situation I found here. Details. Port B available. Oh, I think I have to plug in. All right, yep, port B, start. Let's turn the air conditioner off. See what we get. 44 kilowatts it says, so we don't have any voltage or amps anymore, of course, and we cannot change the current speed anymore because this is now DC. This is DC. It bypasses the internal charger. So this is not restricted to the 11 kilowatt onboard charger anymore. It bypasses the whole AC DC conversion, and the charging station connects directly to your battery now. I should have brought another color. So this is 50 kilowatt. This is 50 kilowatt, and the display shows us 43 kilowatts. And let's see what the dog shows us. It shows us 113 amps times 384 volts, which is 43.3, 43.4. All right. So, and we cannot do the calculation anymore because it doesn't make sense anymore. We don't have any losses at the moment because, as I said before, we are bypassing the internal charger and electronics now. We are connecting directly to the car's battery. So in theory, we don't have any losses anymore. 43 kilowatts is that what goes into the car, and this is exactly the same power which goes into our battery. We will see this later on when I go to the supercharger. We will have the same result. If you charge on DC, you don't have any losses. Quote. Okay, and just after a couple of minutes, we can see the power actually goes up to 45 kilowatts now. And this is because the voltage of the pack rises. So, and if we do another calculation now, we will see 386 times 115. So we are now on 44.4 kilowatts, and it shows us 44 and 45 sometimes. So the actual power going into the car is rising because our voltage of the pack is rising as well. The current will stay pretty much the same, but the voltage will rise. So more power goes into the car. Okay guys, I will charge this 10 minutes here to get to 70%. ChargeFox will now take the money from my credit card, and they have to pay fees for that. So I don't want to be a dick and just charge half a kilowatt hour here. So I charge up the car a little bit, even though I don't need it. But yeah, just to make it worth for them to send me the invoice then later on. It's the same price of energy anyway. It's 20 cents per kilowatt hour. Exactly the same as I would pay at home. So it doesn't really matter where I charge. Of course, while charging DC, we can see the rear motor produces 3 kilowatt of power, which heats up the water, which will heat up the battery to about 50-55 degrees eventually. But I'm not charging that long, only for 10 minutes, so we won't heat up the battery that much. You should sign in via PlugShare, let other people know you're using the charging station, what kind of plug you're using, how long you are charging, and what the maximum charging power is you're getting at the moment. So I just sign in for 15 minutes and then it signs you out automatically again. No big deal, right? Well, what I just saw here, 1, 2, 3, 4. We have only 4 charging sessions in March. We had only 4 charging sessions in February, but we had 9 charging sessions in January when it was still free. So do we see a bit of a trend here that people don't come here anymore to charge just because it costs 20 cents per kilowatt hour? Or is this just lazy people don't sign in via PlugShare anymore? I wish more people would use it. So the charger and PlugShare at the same time, of course.
Checking out is the cargo ship, which I picked up on the AIS. That's another thing that I go through and check that.
So charging has now completed at 80% and the heating has stopped as well. We heated up the battery to 47 degrees, 47.5 degrees. That is insane, right? Because I'm still watching my video here, I'll keep doing that until it's another 6 minutes. But you get the invoice, the bill straight away. So I charged here for 20 minutes, 14.5 kilowatt hours, and the cost is $2.92 Australian. You're good to go. We emailed a tax invoice to me. That is great. And if I check my emails, the invoice is already here. Bang. Okay, let's unplug. Oh, that's a big harvester. Okay, unlock the charge port. And we can see here again 14.5 kilowatt hours, 80% state of charge. And I'll keep charging AC. It's better for the battery, you know. And the good thing with AC is we don't heat up the battery anymore. 0 kilowatt in the motor produced, and the battery will cool down now a little bit. 48 is far too hot, I think. That's why I try to avoid DC charging with the Tesla Model 3 as far as possible. Well, if you're on a trip, of course you have to DC charge, otherwise you get stuck for hours. But at home or on our smaller trips we usually plug into destination chargers or 7 kilowatt chargers, 32 amp one phase, and charge slowly, trickle charge, top up the battery a little bit, and apart from that use the UMC at home, charge AC. Okay, charging has now completed here. I just set it a little bit higher, so keeps charging with 2 amps out of 16 3-phase to keep the climate control up and running. But you can see there's nothing going into the battery anymore, and this is the only power going needed for the air conditioner. So if I turn this one off here, you will see this one goes to 0. Well, at least, oh, now it goes to 0. I was just going to say, at least in theory it goes to 0, but now it does. Okay, let's clean up this mess. Someone left here on the charger. I hate it. That's probably one of the reasons I haven't installed my one at home, because the cable is so thick and unflexible. It's well, it's not funny sometimes, really. And I think it gets only worse in wintertime when the cable is really cold and stiff and you need to fight the cable bending in the right direction, and it's just, you know, that's a 6 square. Okay, so next stop will be the Supercharger, right? To have a look at there. But as you have seen from this 50 kilowatt DC charging already, there is not much going on actually, because there's not much going on because we can't measure any losses. The charger, which has the losses here when you charge DC, is in the charging station. I'll show you. So the 11 kilowatt charger is built in the car, and as soon as you charge on AC, it will use the inbuilt charger. But if you use one of the stations, the charger is actually inside the station, and it bypasses the built-in 11 kilowatt charger. So all the losses are inside the charger, and well, apparently you don't pay for them, right? That's just how it all works. And the same is with the superchargers. Supercharging is bypassing your internal charger, so you don't have any losses in your car. It connects directly to the battery and DC charges it directly. All the losses are on the Tesla side, on the Supercharger side, or on the 50 kilowatt DC charger side. So you don't well, you don't pay for that, or do you? I don't know how they charge you actually here with ChargeFox. Do you pay for the losses? I'm not sure. You definitely pay for the air condition when it's running while you are charging, because you're getting less charging speed into the battery, but yeah, I'm not sure if we can actually figure that out. Here. Well, what I could have done is reset the trip meter before start charging on DC, and then compare this with the kilowatt hours they actually charge you. So this would give us an indication if they actually charge you for the losses inside the charging station. I'm not sure about this, but I will try in the next, when I charge the next time, then I will remember that. The next time I'm coming here, I'll do the test. I think they charge you for the losses actually, because look at this one here. I reset the trip meter a while back and I haven't used any charging stations so far. I always charged at home on AC, and this is the 13.5 kilowatt hours we have just charged. We can see they have charged us for 14.58 kilowatt hours, but in the battery went only 13.5. So give me 13.5 kilowatt hours. So this is exactly 1.08 kilowatt hour loss. So this would mean, if I just go from the kilowatt hours, we've got an efficiency of about 92.6% of this 50 kilowatt charger. So we got a charging loss of 7.4%, which is not too bad actually, but they charge you obviously for that, as you have just seen. Yeah, unfortunately we cannot do this with the supercharging. Doesn't give you any indication how many kilowatt hours you have actually charged. It just tells you it was $0. So we cannot do the same with the supercharging. We don't know the efficiency of supercharging. Did I put some green on the pen here on my steering wheel now? Well, unless someone gets charged from you for supercharging and you have the Tesla watchdog running as well, and you can actually see the difference what Tesla charges you for one charge and how much went into the battery, and then just do the calculation, how good is the efficiency of a supercharger. If one of you can do that, please, that would be awesome. Put this all down in the comment below. First one gets pinned to the top of the comments. Thank you guys. I'm not going to a supercharger right now. I have filmed already the supercharger scene the last time I was there, so watch this right now here. Well, so, and the final test is of course with a Tesla supercharger. I am here at the Gold Coast Fair, Gold Coast Shopping Center, near the Gold Coast. I don't know how it's exactly called. And we plug into a supercharger and see what efficiency we get over here. Unfortunately, we have to share the stall with another Tesla Model 3, but it's the same over here. Let's see how much we get here. 63 kilowatts we get as the second charging vehicle on this stall. And we do get 70... Oh, it's going up, it's going up. Maybe this guy is already full, who knows. 100 kilowatts, 96 it shows us here. So battery current 255 amps. Okay, let's do the maths. So 376 volts times 255 is 96 kilowatt, and that's exactly what we get here. Alright, obviously we cannot see how much energy is going into the battery. It seems like this is exactly what the car shows us when charging DC. This is on a supercharger here at the Gold Coast. 100 kilowatt charging speed. So I have now added the supercharger figures as well. We charged with 96 kilowatt and the Tesla dog showed 377 volts and 255 amps, which is exactly 96.1 kilowatts again. Yeah, unfortunately Tesla does not give you any figures, any kilowatt hours charged into the car. It only gives you kilometers. So if any one of you guys is being charged for supercharging and you have the Tesla Watchdog running as well, can you get some numbers down in the description below and let us know how good the efficiency actually is for supercharging? I'm not sure, but I think it will be similar to 5 or 10% loss. Alright guys, so what do we get out of this situation now? If you charge on AC, yeah, everything above the red line, you want to charge as fast as possible with your UMC, and you want to charge at least 10 amps on 3-phase to give you the maximum charger efficiency of 95%. So everything above 10 amps, it doesn't really make a difference in terms of the efficiency, but of course it gives you a time advantage. The car charges faster. But apart from that, 10 amps is totally fine. You get the same efficiency or the same loss as on 16 amp. And DC bypasses the whole charging situation in your car, connects directly to the battery, and you don't have loss, but they obviously charge you for the loss. And from these two figures, what they have invoiced me and what we have charged into the battery, we are getting about a 7.5% loss or 92.5% efficiency. Yeah guys, let me know down in the description below how you charge your car. And don't forget to head over to patreon.com/unpluggedtv. Support me, support the channel. It's $5 a month, and you get more videos like this, behind the scene videos, live chats, and also be a member of the Unplugged TV WhatsApp group. And thank you to Kiel for signing up to the Patreon community. Thanks for supporting me with $5 a month. And also thank you to Steve, Rob and Chris for joining the $5 tier on Patreon. Thank you very much guys for your support. Alright guys, so far this video from today. Let me know what you think. And you stay charged. And we will see us again in the next video very soon then.